Hello, my name is Peter and I'm going to present a paper number 51, which is an attentional control mechanism for reasoning and learning. Basically, this paper discusses an attentional control mechanism in the context of artificial general intelligence. In particular, attentional control mechanism of OpenRs and implementation of non-axiomatic reasoning system for research purposes is being introduced, its budget functions described, and small example introduced and shown, and budget functions explained in that examples. What is an attention control mechanism and why it's so important? So basically, most, if not all, AGI systems operate on the assumption of insufficient knowledge and resources. Given that assumptions, resources are always finite, and attention control helps manage those resources given to the system. And resources can be anything, can be processing power, can be memory, anything. Attentional control also helps to choose fruitful reasoning steps to allow desired learning and keeps system performance and efficiency high. So in OpenR's, role of attentional control is extremely important. First, OpenRs also operates under assumption of insufficient knowledge and resources, and NARS always expects a new task to arrive at any given moment. So systems is always open to a novel task to come in, and system has to stay responsive all the time. Attentional control allows NARS to work under finite resources constraints, and especially it decides which premises should be selected for inference in real time during current system cycle. So during inference, there are multiple premises to choose from, usually many premises to choose from, and choosing the premises which brings the system closer toward the goal resolution are most desired, and this is the job of the attentional control mechanism. Then it also influences the future learning vector, final resolution of the supplied tasks, and overall performance and efficiency of the NARS system. Attentional control mechanism can be of many forms. It can be very simply implemented or very more sophisticated, but it turns out that most, or if not all, AGI systems uses it using it in any of the forms. So effective attentional control usually is a part of or embedded in main control part and operates during each inference step in the real-time processing. Simple attentional control may be implemented as a data filtering, just using data selection, saliency assigning, information filtering. Such control prevents the AGI system from information overloads, thus protects it from too much information and allows the system to continuously be responsive. More sophisticated control mechanisms are there, like in OpenRs or in OpenClock, for example. They use multiple parameters to evaluate multiple level importance of data items and complex procedures to manipulate those parameters. Whenever we speak about attentional control, it's hard not to mention the previous AGI systems which are out there, and some of them use very sophisticated attentional controls. So for example, the early project Copycat, which is a computer program which for the very small domain, narrow domain, but still it has a very interesting attentional control mechanism. It uses parallel trace scan as a resource allocation mechanism. Attention decides which structure in the workspace to develop and which codelets in the code rack should be allowed to work based on saliency, urgency, and probability. Workspace and code rack are two components within the Copycat program. LiDAR is another interesting system, immensely complex, very difficult, and its attention is implemented as a filtering process. We're using attention codelets that looks for interesting situations within the workspace and episodic memory. Those codelets form a coalition of data and bring it to the consciousness. Consciousness is being implemented as a global workspace. It's one of the components in the LiDAR, within the LiDAR. Another brilliant system is ERA. Attention in ERA continuously controls input saliency within specified short time horizon, resulting in a reduction of inputs to the models. So basically, within the specified short time horizon, it just becomes the data filtering, input filtering to the models, which keeps the system responsive. And of course, OpenCook Prime, very sophisticated systems, it uses economic attentional networks, econs, as a way for attentional control and resource allocation. Equations used in econ are based on the economic ideas control, and those equations control evaluate short and long-term importance of the atom. Atom in econ is any data item, can be looked in the node in the graph or link in the graph. They call it atom. Whenever we speak about attentional control in OpenRs, it's impossible not to mention, at least briefly, the general overview, general design of the main control part. Partially because the attentional control is deeply embedded in the architecture through the use of main memory, concept memory, which is concept memory, and data structure, which is called bag. So the main memory follows a concept-centric memory structure in accordance with the term logic. It can be viewed as a hypergraph with concepts represented as nodes linked by different types of links, so there are multiple links between the nodes. Those links are task links to the tasks, term links to the terms, and belief link in just a special case of the term links. There is a bag data structure. Bag is a main component of the system that allows attentional mechanism to efficiently operate. Bag is a data structure where the elements are sorted according to their priority, and the sampling operation chooses the candidates with selection chance proportional to their probability. That means that in the bag there are items with lower probability, with lower priority, but they also given the chance to compete for the resources. Attentional control operates dynamically in OpenRs within system cycles in real time by employing budget values, truth values, and budget functions. Budget value and truth values are two very key features of OpenRs. Since we're speaking about attentional control mechanism, so the budget values is the most important. Budget value is the set of three rational numbers assigned to each data item, so it can be assigned to the concept or to the link that controls resources to be dedicated for a data item. So budget value consists of three numbers which are priority, durability, and quality. Priority is the measure of short-term importance. During the inference, I have to choose the item now. I have to choose it based on priority. So it's very short-term urgency importance. Whenever I completed the inference, I have to put my item, data item, the concept, for example, back to the memory. But I already completed the inference, so I already kind of spent the time on it and resources, and I want the priority to be decreased such that other concepts will participate into the resource competition. And how do I decrease the priority? Is basically with the use of durability. Durability is nothing but a decay rate, which describes how fast priority of an item should decay. Basically, I multiply priority by durability, and durability and priority becomes less, it's decreasing, because all of the parameters within the budget value or truth value, priority, durability, quality, are all within the range from 0 to 1. And the quality, the last parameter, is basically the long-term importance of the data item. Now, the truth value is a set of two rational numbers which indicates degree of belief based on the evidence collected from systems experience. Truth value consists of frequency and confidence. Frequency is nothing but the amount of positive evidence divided by total evidence, and the confidence indicates degree of reliability of corresponding frequency. OpenRs always has an operating cycle. Whenever it works, the operating cycle works like a while true loop. So main operating cycle is a data-driven, guided by the priority of data items. The operating cycle is as follows. I will show the diagram later and try to go over it. So we first add things from the global buffer into the main memory. So we add the concept to the concept memory, for example. When we select the concept, then we select the concept from the main memory. Then we select the task link from the concept. Then we select the term link from the concept, from the same concept. Then we obtain the highest confident belief from the concept the term link points to. Then we apply inference rule within the task link's task and beliefs as premises. Then we adjust the budget value, through use of budget functions for data items participated in the inference. And finally, we input conclusions into the global buffer. Here is a diagram. Their tasks: Raven is bird is animal, and the concept are yellow. And we can see the red arrows are the task links and the blue arrows are term links. So we select the concept, for example, bird, then we select the task link, which is the red one going to the here to the Raven is bird. Then we select the term link, which for example can be whatever, can be pointing over here, bird is an animal, and we select the belief from here, and that belief becomes the one premise and the task becomes the second premise. Then we basically make an inference and adjust the budget value and truth value for the derivation, and also adjust the budget value for this task and the concepts. Now, while we've been doing the attentional control, there are some criteria to consider. First of all, data structures are always bounded in size, so eviction policies has to be in place, and system always has to be responsive for the new inputs and derivation. Also, operating cycle needs always be finished roughly in a constant time. Single inference step never can be interrupted by the important tasks. However, the important task is able to interrupt all the work carried out over the multiple cycles. And when the important task is over, the system has to return to whatever it was doing before. Also, we need to make note that short and long-term importance. When we select, the selection is always reflected by the priority, which is the short-term importance, while the forgetting relies on quality of the item. When derivation is complete, the budget value obtained by budget inference is changed based on how much of a related task is being fulfilled. So budget inference always updates the budget after each inference. And of course, OpenRS implements relative forgetting, which means similar to information filtering. Whenever the item is put back to the bag data structure, its priority is being decreased to allow fair competition for resources. Once priority becomes the lowest, it's removed from the memory if the new data item comes to the data structure and data structure is full. So here is the most important budget functions which update the budget values. It's impossible to have all the details laid out on the table because of the time and the format of the presentation, but these are the most important. So we have the budget inference. Budget inference is nothing but updates the budget value for tasks and terms after each inference. There is a merge function which merges two budget values. There is activate function which activates the concept by the task links priority or task link priority, yes. And there is a revise budget functions which after revision revises the budget value given the truth values of the task, term, and the conclusion. So basically revises the budget value of the conclusion. Please note there is functions like OR function or AND function or truth to quality functions. Those are predefined, pre-programmed formulas which we call utility functions. So budget function operate on top of utility functions. So we can just say that it's just only formula used. Now there is an experiment. I think we can go over it for a minute. So the user enters in the system two sentences. The cat is an animal over here and dog is an animal. This is a default. On the right is a truth value, which is the frequency and confidence. 1.0 is frequency, 0.9 is confidence. On the left, three values are the budget value. So by default, 0.8 is for priority and durability. 0.95 is being computed during the initialization stage with a truth to quality. So we have the quality and then we apply the truth to quality formula and we get the 0.25. Then with processing the steps, we put them into the memory when the system cycle starts, once it's in the memory. So we select the concept, animal, and we select the task link, which basically points to the cat as an animal, and we select the term link, which points to the dog as an animal. So when we've been doing the initialization phase, those are being assigned the priority, durability, and quality. The priority is defined using that using that parent's task link priority divided by the number of terms it uses, number of links, and it appears that each of the inputs has the two terms. Then then 0.8, which is the parent's priority, we divide by square root of 2, and we get this number. So then we go to the dog as an animal concept, select the belief there, and the highest confidence belief is a dog as an animal. Then we apply inference rule for the dog as an animal and the cat as an animal. And we have the derivation. Derivation is over here. So derivation is a cat and dog are animals. On the right is the truth value. On the left is the budget values. So we assign 0.9131 here as a priority of item based on, and all of these budget values is being assigned based on this table budget inference, which is O utility function, and truth to quality utility functions. Now I'm running out of time, so I briefly describe the similarities between different systems. So OpenR's is partially very similar. Is partially similar to Econ's OpenCog's economical networks in a way that its attentional control is embedded in architecture and employs budget functions, similar to the economical formulas, which are predefined formulas that updates short-term or long-term importance, which is in the case of OpenR's its priority or durability. OpenR's resource allocation ideas share similarity with copycats. For example, parallel trie scan is very similar to the back data structure selection. OpenR's also features the spread of attention and data filtering using the relative forgetting. And spread of attention is basically happens within the data items that are related to ones participated in the inference. Thank you. And I'm out of time.